As promised during Tuesday's class, I said that I would make a video reviewing how to use the quadratic formula and then how to simplify anything that we have under the radical when we finished using the formula, because we always need to simplify. And Tuesday, after the test and everything else that went on, we were all pretty tired when it came to this example. So I'm going to do the quadratic formula part of this example again. So this here, the function we were given, the quadratic, f of x is equal to negative x squared plus 4x plus 1. And we want to solve this, set this equal to 0, and solve when we were looking for the x-intercepts. So to solve quadratic equations, we are able to potentially take the square root of both sides, as we did in some of the other examples. We can't do that in this form. We'd have a lot of work to do to be able to do that. We could potentially factor. This problem can't be factored. So we are left then to use the quadratic formula, which is x is equal to the opposite of b plus or minus square root b squared minus 4 times a times c, all that's under the radical, and this is all over 2a. Now, a, b, and c are just the coefficients from our function. So when we look at the x squared term, a is what's in front of the x squared term. We're not seeing a number, so that is our invisible 1. And because this is negative, it's a negative 1. B is the coefficient in front of the linear x term. So B here is 4. And last but not least, C is the constant at the end. So in this example, C is 1. So now we come here and we start to do our substitutions. Remember, this says the opposite of B. So in our example here, B is positive 4. So this is going to be negative 4 plus or minus. B is 4, so I'll write that in 4 squared minus 4. A is negative 1 and C is 1, all over 2 times 1. Negative 1, because our A is negative 1. Would help if you could see. So you know what, this is kind of negative 1. There's our A there, negative 1. So that's doing the substitutions. Now let's start cranking out the calculations. So x is equal to negative 4 plus or minus 4 squared is 16. And then here, negative 4 times negative 1 is positive 4. Positive 4 times 1 is 4. So we have 16 plus 4 under the radical. And then down here, 2 times negative 1 is negative 2. Continuing on, negative 4 plus or minus 16 plus 4 is 20, all over negative 2. So this is the answer that we have, but we are not quite done yet, because we always need to simplify. In math, whenever we have a fraction or a statement, we always look to simplify it as much as possible. So we have this square root 20. By simplifying here, what we want to do is to pull out what we can under this radical. So what I'm going to do is, for now, let's leave that, and let's take a look at simplifying this square root of 20. So there's 2 ways you can do this. One is to look at factors of 20. So let's consider factors of 20. We have 2 times 10, but we want one of them to be a perfect square. Neither 2 nor 10 is a perfect square. Other factors of 20 would be 4 times 5. That's useful because the 4 is a perfect square. So we can break 20 down as the square root of 4 times the square root of 5. And now the square root of 4 is 2. So we can take that out of the square root symbol, and the square root of 5 just sits there. We can't do anything. That 5 is not a perfect square. Another way that you might be able to simplify these, if you're not seeing the factoring, is to take the 20 and break it down into its factors. It would be 2 times 10, and then 10 is 2 times 5. So the factors of 20, 2, 2, and 5. So this is just another approach to simplify. So we could replace the square root of 20 with its factors. 2 times 2 times 5. We're just listing all the prime factors. Now this method works for simplifying square root, cube roots, any kind of root that we might be looking at. This process of factoring is the same. What's different here is how many of the same factor we need underneath in order to pull one out. For square roots, we need 2 factors, 2 identical factors underneath the radical in order to pull one out. So we have 2 and 2. So I'm crossing those out because I can pull the 1, 2 outside. So rewriting this, 2 square root 5, we get the same answer. It's just a different approach thinking about it. So let's go back here. The whole point of doing this was we had this statement here. So we have our negative 4. Now I'm going to replace the square root of 20 with the 2 square root 5 in its simplified form all over negative 2. Now we can look and consider, can we simplify? In order to get rid of this negative 2 in the bottom, we have to be able to pull a 2 out from this first term and the second term, which we are able to do now because 4 can be divided by 2 and the 2 can be divided by 2. So let's do the division. In fact, what I'm going to do is I'm going to break this up into 2 fractions for any of you. So all I did was take this 1 fraction and divide it up into 2 statements for any of you that might need a little bit more clarification on how this would reduce. Now, negative 4 divided by negative 2 is positive 2. 4 divided by 2 is 2. Negative, negative is positive, or plus or minus. And then here, 2 divided by negative 2 would be negative 1. So I'm going to write it in now. Negative 1 square root 5. However, because this is plus minus here, which says consider both the positive and negative roots, this negative sign doesn't really come into play in our final answer. If we wanted to, we could switch up our final answer. It's kind of hard to see there. 2 minus, it doesn't really change it. I just flipped the positive was on top and then the negative, I just switched them because we are considering both roots, positive and negative.